Hello and welcome to third unit Feedback Amplifiers Part 1. Myself Sanjit Kumar Singh, lecturer in Electronics and Telecommunication Department at Praveen Patil College of Diploma Engineering and Technology. This unit 3 Feedback Amplifiers is of 12 marks and 12 hours allocated for it. Topics to learn in this presentation Part 1 is principle of feedback amplifier. Then we will also learn types of feedback, negative and positive feedback, advantages and disadvantages of negative and positive feedback, and the rest of the topics, types of feedback, connections, will be covered in the second part. So after going through this presentation and the part 2 presentation, the learner are expected to have the knowledge of how to calculate the gain of the amplifier for the given type of feedback amplifier, explain effect of negative feedback on the given type of amplifier performance, calculate gain, bandwidth, input and output resistance of the given feedback amplifier, and fourth, compare the performance of the given types of negative feedback amplifiers. The course outcome of third chapter, third unit is to use BJT as feedback amplifier. So first we must understand what is feedback, what do you mean by feedback, and what are feedback amplifiers. So feedback is a process of injecting some energy from the output and then return it back to the input. The amplifiers which use the feedback principle are called feedback amplifiers. The feedback amplifiers basically consist of two parts. These are the amplifier circuit and the feedback circuit or network. This feedback is taken so that we can improve upon some of the derivations, some of the difficulties in maintaining the performance of the amplifier as per desired, or to remove or to minimize the effect of the non-linearity of the transistor characteristics, the parameters variation, temperature effects, etc. So most of these drawbacks or limitations can be overcome with the help of the feedback technique. So depending upon whether the feedback signal increases or decreases the input signal, two basic types of feedback in amplifiers are used. That is the positive feedback, and second one is negative feedback. So let's see the principle of feedback amplifier. The block diagram adjacent shows a part of the output voltage is feedback to the input of the amplifier. So without feedback, the amplifier gain A will be the ratio of V out upon Vi. If feedback is given, Vf comes to the input side, so this feedback voltage will be either in additive mode or subtractive mode with the Vs. Therefore the input voltage Vi changes as Vs plus Vf, that is equal to Vs plus beta times V0 for the positive feedback, and Vi is equal to Vs minus Vf, that is also equal to Vs minus beta times V0 for the negative feedback. So remember, for the positive feedback, the total phase shift will be 360 degree. That means the amplifier will be providing 180 degree phase shift, and another 180 degree phase shift will be provided by the feedback circuit. And for the negative feedback amplifier, the amplifier will be providing 180 degree phase shift, whereas the feedback circuit is designed in such a way that it is not providing any phase shift. That means the output will be 180 degree phase shifted with respect to the input Vi. That then it will be a negative feedback. So beta, what is the beta? Beta is the feedback fraction that is equal to Vf by V0, and it is also called feedback ratio. The negative feedback, for negative feedback, the output V0 must be equal to the input's voltage, that is Vs minus beta times V0 multiplied by the gain A of the amplifier. So substituting that we get Vs minus beta times V0 multiplied with the open loop gain A equal to V0. Solving it further, we get A multiplied with Vs minus A beta times V0 is equal to V0. So solving it for AVS and taking the second term on the right hand side, negative term on the right hand side, it will become plus, and from there we take out the V out common. We are taking the V out common, and therefore it is V out within bracket 1 plus A times beta, that is the product of the amplifier gain into the feedback factor. Therefore the voltage gain with feedback A dash, or that is also represented as AF, is equal to V0 by Vs, that is equal to A, the open loop gain, by 1 plus A times beta. Now let AF be the overall voltage gain, that is with the feedback of the amplifier. This is defined as the ratio of the output voltage V out to the applied signal voltage Vs. So from the above two equations, we can understand that the equation of a gain of the feedback amplifier with negative feedback is given as AF is equal to A divided by 1 plus A beta, and for positive feedback it is AF, the gain of the amplifier with feedback is equal to A, the open loop gain, by 1 minus A times beta. So these are two standard equations to calculate the gain of the feedback amplifiers. Now types of the feedback amplifiers, we have the positive feedback amplifiers and the negative feedback amplifiers. First we will see the positive feedback amplifiers. The feedback, what is this positive feedback? The feedback in which the feedback energy, the feedback signal, is either, that is either voltage or current, is in phase with the input signal and thus aids it with the input, and it is also called regenerative or direct feedback. So both the input signal and the feedback signal introduces 180-degree phase shift each, thus making total phase shift around the loop is equal to 360-degree. That means that is equal to 0-degree phase shift, that is output is in phase with the input. So what are the advantages of the positive feedback? By positive feedback, the gain of the overall gain of the amplifier increases, whereas the drawbacks, disadvantage of this is that it increases also the distortion, and it results into unstable operation as the input goes on increasing. So what are the applications now? So this type are not recommended for amplifiers but are recommended for, useful for producing oscillation by the oscillator circuits. Now for the negative feedback amplifiers, of course the feedback signal or the energy has to be out of phase with the input, and thus it will oppose the input, reducing the input, and is also called degenerative feedback or inverse feedback. So in the negative feedback, we have the amplifier introducing 180-degree phase shift, and with the feedback circuit is designed to have 0-degree phase shift. Therefore output will be 180-degree out of phase with the input. So that will result into subtractive mode of operation and on the input side. That means the input reduces compared to the positive feedback or the initial input signal. Disadvantage, what are the disadvantages? The major disadvantage is that the gain of the negative feedback amplifier is reduced. As the input is reduced with the subtractive feedback signal, the output voltage also increases, the gain also increases, the gain decreases, sorry. For the voltage feedback, the output is taken in shunt connection, that is parallel connection, and for the current as feedback, the output is taken in series connection. So that is the sampling part on the output side, how the samples are taken, voltage sample or the current sample. So there are two main types of negative feedback circuits, that are negative voltage feedback or negative current feedback. Now let's see the advantages of negative feedback. There are many advantages, and one drawback we have seen, that is the decrease in the gain, overall gain of the amplifier, but we have many advantages. First one is the stability of the gain is improved of the amplifier with the negative feedback. Second is the reduction in distortion, the distortion level is also decreased. Reduction in noise, increase in input impedance, the input impedance is increased whereas output impedance is decreased, and it also increases the bandwidth as it lowers the lower cutoff frequency and increases the upper cutoff frequency. So these are the major advantages, and questions are asked in MSBT paper on advantages of negative feedback for 4 marks. So here we have the equation relation to show how the increase or decrease in the values of the negative feedback circuit takes place. First one, the stability of the gain is improved. Here we can see by a factor 1 plus beta times AV, where AV is the open loop gain and AV dash is the with feedback, the gain of the loop gain of the negative feedback amplifier. So reduction in distortion, similarly D dash, the new distortion D dash is equal to the open loop distortion divided by 1 plus beta times AV. So here we also see the reduction in the distortion. Similarly, reduction in noise is by a factor 1 plus beta times AV, and increase in input or decrease in output is also by 1 plus beta times AV, and increase in bandwidth is also 1 plus beta times AV. So 1 plus beta times AV is a factor by which the parameters are either increased or decreased. So here we can compare, to summarize it, the positive and negative feedback amplifiers. First, the positive feedback amplifier is the one in which the feedback signal is in phase with the input signal, whereas in negative feedback, the feedback taken from the output is out of phase with the input, that is subtractive mode with the input. The second, overall input signal, due to the positive feedback, we have the input increased, Vi is increased, that is Vs plus Vf, whereas in negative feedback it will decrease due to the negative signal fed to the input. Gain in positive feedback it increases due to the increase in the input, and in negative feedback amplifiers the gain decreases. Similarly, the noise will also increase in positive feedback and noise is reduced in the negative feedback. Stability is poor in positive feedback, whereas it is better improved in negative feedback. And the application we find, the positive feedback amplifiers or positive feedback is used in oscillators, whereas the negative feedback amplifiers are mostly used in amplification, the amplifiers. So here we have a simple numerical based on the theory we have seen so far. The voltage gain without feedback is, that is AV is given as, or A is given as 3000, and the feedback factor is given as beta is equal to 0.01 in the first numerical. So we have to calculate the feedback gain, or gain with the feedback. So AV dash or A dash is equal to the open loop gain by 1 plus A, the open loop gain, times beta feedback factor, that is substituting the values we get 96.77. and in second numerical we have been given the open loop gain as 1000, beta the feedback factor as 0.04, and the change in the open loop gain is 10%. Now we have to find the percentage of change in closed loop gain, that is d A dash by A dash. A dash is the gain of the amplifier with feedback, and A is the open loop gain without feedback. So that value is calculated by 1 divided by 1 plus beta times A into dA by A, that is substituting the value we get 0.244% change with the closed loop gain of the amplifier. So here is the summary of what we learned in this presentation. First we saw the feedback, what is feedbacks, and how feedback amplifiers are performing. There are two main parts, remember, the amplifier circuit and the second one is the feedback circuit, and depending upon whether the feedback signal is in additive mode with the original input or in subtractive mode, then accordingly we have the positive feedback and the negative feedback. Then depending upon whether the sample taken from the outside is in parallel or in series, if it is in parallel like the diagram shown, then it is the voltage feedback or sampling taking place from the output side, and if we are connecting the two wires to the lower side of the amplifier, then the current sampling takes place, and on the input side when it is fed as shown in the diagram, then it is series fed, and when the two wires are connected to two different wires of the input, then it is the shunt feedback. So in that way we have seen the positive and negative feedback. For positive feedback, output is sampled and fed in additive mode, whereas for negative feedback it is in subtractive mode. And we have seen the advantages of the positive feedback. The output increases but results into many drawbacks, unstable operation and increase in the noise and distortions, whereas for the negative feedback the output gain, overall gain with the feedback is reduced, but there are many advantages with the stability, improved reduction in distortion, reduction in noise, increase in input impedance, decrease in output impedance, and increase in bandwidth. So that's it. Thank you. The references one can go through. Thank you.